now move on to the next presentation. We have with us Mr. Miguel from a company called Aqua Tuta, basically based in Spain, and they are working on water treatment. They have a very innovative technology. I am very sure that with this presentation, you will all visit their store.
CapEx and OpEx is dramatically reduced, the cost. And at the same time, as it's extremely powerful, it has the smallest area of footprint. It's 2 square meters. Now, what does it consist of? It consists of a molecule crusher that will facilitate the flocculation of the contaminants in the treatment deposit. And then after that, the molecule crusher is on the left. And after that, 2 brains start analyzing the water real time and sending out signals in the treatment deposit in order to remove them. But we don't flocculate downwards. We flocculate upwards. So our paddle system in the deposit tank can remove the contaminants. And this is what this slide shows. And at the same time as we remove the contaminants, if it's organic matter, nitrogen and phosphorus will be present. And we will separate those automatically so that the client can actually get them in a separate container. Now this is just a quick shot of a sugar lagoon in, I think it's Latin American. So to the left you have a sugar lagoon, dirty as hell, you've probably seen it if you're in the business. And to the right you have the same lagoon, dirty as hell, but they asked us to suck up the water, the effluent, and return the processed clean water that you see pouring out through the tube. Here we go again. We eliminate the heavy metals. To the left, you can see the container, or whatever you want to call it, where the pink heavy metals are. And to the right, you see the tube running in. You can see that it's clean. It's the same picture or the same material that we saw in the 2 bottles before. Here is coffee effluents from Latin America. To the left, the dirty coffee effluents, and to the right, Aqua Tuta's processed water. We work well in a jungle environment, and we work well because of the fact that our robust machine can stand in a very small surface and not occupy too much space, neither area-wise or height-wise. It's only 1.2 meters high. These are some of the company's effluents that we have treated with success, great success. I think everybody knows these companies, maybe not AB InBev, but AB InBev is the biggest brewery in the world. They make Stella Artois, they make Budweiser. JB is a sugar company, Palminas, in Costa Rica. Many of our clients, what they do is that they have them, because of the size, they can have our machines installed in the cellar and treat the water from the shower and the hand basins or the sinks or what have you, and recycle it to the toilet bowls. Now, we don't want to be worse than anybody else who's been up here speaking, so please come and visit us at our store, PS06. You see it up there. And my details are here. Thank you for listening.
Asking you what would be the operational cost.
Yeah, of course, of course. And it's a very good question, but it depends on the effluent. And for example, in Costa Rica or Mexico, if you have Mexico, that's not coffee, but in Costa Rica, for example, the coffee effluent is different than in Brazil or in Colombia. So I could be telling you any number, but what we've done in order to basically enlighten you is that we're working with VSI to install an industrial unit of our Aqua Tuta that if you want to visit us, we'll be happy to invite you under VSI supervision so you can see how it works. And then we can also tell you exactly what the operational cost is on site. Because at the same time, there are many factors that decide the operational cost. So I don't want to throw a figure at you and then be totally wrong, which it's very unusual to the dislike of my girlfriend, but what can I do?
Batch or continuous process? So operation is continuous or batch?
No, continuous. We do 240, do you want to take that phone? We do 240 cubic meters per 24 hours, so we're incredibly effective. It basically boils down to 4 cents per cubic meter or 3 rupees. $240 cubic meters per 24 hours. Up to, yes. Depends on the effort. Say again? Well, if you need, well, then you need to buy another unit. One unit can do up to 240 cubic meters for one unit, but we welcome you to buy two. If the unit is plug and play, well, basically the way this works is that we install the unit, and the unit uses only standard irrigation equipment. So if anything breaks, you just run over to your hardware store, you buy whatever is there, you know, tube or whatever. But the system is plugged in the wall, connected to the effluent tubes. But let me just add something since you said that. It's obviously something very new. You know, you can't drastically reduce size and cost and OpEx and have people believe you. So we understand this problem. And what we're offering here is for whoever is interested, with VSI and ourselves, to come and visit the industrial unit working on site here in Maharashtra state.
Great. So you know that VSI and Aqua Tuta, we will work on the industrial unit. But being a scientist or technologist, I am still curious. Still it is a black box for me. I don't know what is there inside. So what is the basic principle on which you work?
This is basically the black box, and you know, I could say, I mean, you know how many black boxes have disappeared, right? But this black box is not going to disappear, because this black box is basically the deposit box of this machine. See there? To the left, you can see that on the back, the red oval, that's the molecule crusher. So the water or the effluent will pass through the molecule crusher and facilitate the brains analyzing the water and separating the couldn't tell you what we're here right now. But we're not talking about sending a rocket to the moon. It's very, the cost has dramatically been reduced. Yeah, electrical power, we need to rotate the paddles. How much is in kilowatts? I can't remember, but I believe that we got something like $14 per 24 hours. 14. Say again? To rotate the power with the paddles to separate the contaminants. If you're, for example, doing sugar, what? Oh, I'm sorry.
My question was like when the water what comes out, is there any effluent what comes out? Is it some type of hazardous or anything like that? That's the first question. Second one is what is the water recovery what happens? Like in terms of percentage.
So basically he's trying to ask in the sense that Rajesh is trying to ask one part is, hey, we understand that you're giving us feedback. Do you also have a reject stream like in the RO? Do you have some sort of a reject stream or something like that? Number one, I think. Am I right?
Yes.
Okay, fair. Your second part even I didn't get, so you'll have to repeat it.
I mean, is there any hazardous what comes out? Like for example, in the
Fact.
you said mercury and molybdenum
Yeah.
contribute.
So so mainly the question is, are you only generating one stream, that is the clear water? Are you generating any other stream? And if you are generating any other dirty stream, is it toxic, is it hazardous, so on and so forth. Fair?
You see the machine there? I'll start with question number 2. Through that chute, the aluminum chute, that's where you get the contaminants. So if you're doing sugar effluents, you're going to get a lot of nitrogen and phosphorus that you can use for your fertilizers. Okay? If obviously you are cleaning heavy metal effluents, then through the same chute, I'm not talking about sugar now, then you're going to get the heavy metals. But in the case of heavy metals, you do want to get the heavy metals separated, so it's very easy to box them when they come out through that chute. Now the reason why I took question number 2 first is because I had a terrible memory. What was the first question?
Do you generate a dirty stream? And if so, how dirty is it?
Well, we for example, let me give you an example if I understand your question right? COD, for example, in Colombia of sugar can be up to 40,000 ppm. We can reduce because we calibrate the machine. In India, I think you have 100. In Colombia, it's 600 ppm. In Costa Rica, it's 300. So we can calibrate the machine so that we can go, for example, in India, under 100 ppm. But it's different from the water that is clean, because Aqua Tuta, what it means is safe water.
Sir, is it increases pH? Is pH is less? Hello. Sir, is pH is less, then is it applicable? This,
That's a very good question. I like that question because that's exactly what the machine does. So for example, in sugar effluents, we've had anywhere from 3.1 to 4 point something, and it's very acid. So as we treat the water, the pH, it goes more up to 7.
can we use this machine for distillery petrol?
Yes.
Distilleries,
Yes, the distillery effluents. Yes, absolutely. Oh, sorry, I'm going.
That is what we are going to try now.
Yeah, absolutely.
My general knowledge doesn't permit me register concept. Good water settles down and the heavy molecules float out. How the
Do you see the screen? Okay. First it passes through the molecule crusher that facilitates the flocculation. This is very important because if the flocculation is the same in the material, in the effluent, as it was when it went in, you're going to have a problem flocculating it upwards and remaining upwards. Right? So by facilitating that, then the brains can push the contaminants up. Now, in order for the contaminants to remain up, it is necessary to have the paddle system moving continuously. Because otherwise, if you let it stay on the surface because it's heavier than clean water, it's going to drop to the bottom. So this has to be a synchronized process. I don't know if this helped you jump to another at all.
No, that is what we are going to install the unit.
Yeah.
So thank you, Miguel.
Oh, thank you, guys.
He is available for next 2 days, and if you are interested, you can definitely go and meet him. We have next speaker with us, Mr. Narayan. Basically a master's in environmental about 15 years of experience, has a number of research papers and patents to his credit in the field of water and wastewater. He has worked and you will try to find out what is this technology. If you ask